class. If you look at the 20 summer workshop, I've got codes and then documents. And today you might, because I've edited it, look at documents and pump up the intermediate outline, which is in documents, 00 intermediate outline. Is that will have a good flow of our discussion today, I think. And that also will test to see if you guys are getting access to it and do it. And please do save codes, things of that nature, and zip me notes.
Yeah.
Earlier on, there's several people that get me emails, and I try to answer the questions here or on code or otherwise, and we'll just see how that goes.
Can someone pop that link in the chat? Does someone have that open already that we could just pop in the chat for people who don't have access to that? That'd be helpful. If not, I will, when Don starts talking, I'll pop that link in. Okay. Oh, there it is. Thank you, Charlie. And just a side note, I'm going to drop off a little earlier today. If any of you have students who are taking Steve Edelman's autonomous car camp virtually, anybody? Nope. I don't see any hands. All right. They're doing a showcase at 1:30. Just wanted to let you know that that's rolling along. The neat thing.
I was going to say, so you're requesting they leave our class to go to that. That's what you're suggesting.
Sorry, yeah. Got another date today, Don. Sorry. But I'll see you again soon.
So I get 3/4 of the group leaving. At least they can use that rather than saying, Kirkwood, this is pitiful. So that's good.
Sorry.
It worked out well. That was nice, Kathy.
Sorry.
One other question about the Google Drive is how long is that Google Drive going to be up, and so that we can pull it over into our own Google before it goes poof?
So you're looking at the two people who are managing that Google Drive.
Well, I don't know. You're pointing at Kat and Cece right
I'm sorry,
now.
Dawn. So Dawn's this way to me. Dawn and I are the ones managing that. As soon as Dawn tells me to take it down, I take it down. But I think we're just going to leave it up forever.
Yeah.
Personally, I think I will do that. As a matter of fact, people who like when Johnny, I love her giving me homework. I thought that was real nice, real nice. This is backwards. It's not supposed to go that way.
Yes, it is. Yes.
Right.
See,
but
coach it
I
up well.
kind of have already started on that, developing some projects that are scalable and build some skeletons to that. And we'll talk about that in the intro class more next Tuesday relative to methods, functions, and so forth. Although we probably will bring that too. But I will continually add stuff to that relative to people who request things of me. So I can't see any reason to take it down unless you guys, so I think that'd be a great place to share stuff. And if you email me stuff, I will attempt to respond to things that way.
I have a question
Jan, well, I was going to say, Jan, to your question in chat, if there's something that you're looking for that's no longer on our website, we did do a revamp of our website a couple years ago. If there's something specific you're looking for, let me know. I'll probably find it in my archives. Kim had something?
Yeah, Kathy, on the thing with Steve Edelman.
Yes.
That's the, no, I don't know how to say it, but the workshop that they have kids come to that have had C++ or
yes,
or
they
Java,
build.
sorry, Java.
Yes, they build that autonomous car, and they work with Portland State.
Yes,
And
so I have 2 kids from Skyview that should be participating in that. I haven't heard anything about the thing today, so.
So we're doing an internal evaluation of the program. So we're trying to help with that. So it's for internal people.
So it's not for the kids to do something?
Showcases on Friday night, from what I understand.
Oh, okay. I'll have to email them. Thanks.
Yep. I will let them know when I'm in there today to make sure they post that. All right, Kirkwood. I'm done talking for now, I think.
Oh, yeah. We'll see.
Hard to say.
This is a side before we get kind of going to the topic. Several of you guys, and it came up in the conversation last week, as you get into this more and more, which I hope you do, especially this is more for the high school people, please do connect with your local community college or wherever it is, because there's college credit now. That's what we used to call it. I don't know if we have new jargon. There may be a new state superintendent, so they put some new title on for the exact same thing. I don't know. But check into those things because they are radically different from community college to community college. So sometimes you get to know one, that may be your only option, but sometimes you can look around and see other places that you can link to that may be more flexible or may be more appropriate relative to what you're teaching. But there are, I think it's really cool. It's really essential for us to let our kids know that there are hoops out there. And at times you got to jump through them, and they need it. And the hoops are different for different universities, and different states, and different processes. Like I said, the IB, AP, and college credit now, all three of them are phenomenal. But you got to make sure they are working to help your students, not hinder your students in different ways. And professional models for universities, sometimes those will actually hurt them, as I alluded to last week. Other times they're just astonishingly good and required, like some of the California states and the Utah state schools. So make sure, if you're into that, that you kind of check into these things. It's kind of nice web pages. I always have the kids contact the department heads of the universities that they're thinking about going to and asking them, how do you handle this? Because here in Oregon, state colleges and every private college handles them completely different. And community colleges say they're supposed to have a transferable degree. And yet I know our son did that and transferred, and 2 or 3 of the classes did not transfer, even though it is a state mandated transfer degree. So you don't want to be paying for something that is not going to do you any good. And so that, especially nowadays with the finances and the structures that are. So think about that. In the intro group, we shared something that I'm not going to be sharing today because most of you would be redundant for, and that is a PowerPoint relative to careers and processes and sequence. It had a whole plethora of stuff intermingled to it. But please take stuff too, because I'd like to add to it. Kathy kicked me a link this morning relative to the pandemic and tech employment right now. And it is a rather unique one, which was different than I have seen, and mine's all anecdotal because both our sons are involved and a whole bunch of friends are involved. So I'm seeing what's going on with them, which is pretty astonishing. But it sounded like overall, like how the trend was that actually tech hiring was lower than some of the other hiring at this moment in time, which was a little quirky. But kick those things and I will add them to that PowerPoint. I kind of have it grow and modulate relative to what's going on at the present. Before we get kicking into syntax and semantics and our big topic of the day, our word of today is algorithm. That's our word of the day. And so before we get kicking into that, are there any questions or comments relative to what we're going to be doing for the next 2 hours?
Do we have to be able to spell algorithm? Because I never get that one right.
No, you can do it on your own. Put a Y in there, what the heck, it's creative. It's like names. My wife teaches primary and every name is spelled 15 different ways nowadays. You know, so just go for it. As an English teacher, I say, oh, why not?
Kirkwood, long-time listener, first-time caller. Quick question. When it comes to Python and what we're doing with this course, are we going to be jumping into how it can be combined or coordinated with like JavaScript and web development, HTML, CSS, that kind of stuff?
With a 4-session, 2 hours each session, the answer to that question was no.
Cool.
But in all honesty, just the time component. Now, what I would recommend is, I know Judson does, don't you do JavaScript and stuff, Judson, or someone was alluding to JavaScript. I would recommend you guys connect, because I don't do JavaScript. I do Java, I do C++, I do C. I mean, those are the stuff I do. So in reality, the groups that do other sort of either path, any pathway you do, connect with each other and figure out those transitions and how that works. Yeah, Judson, sorry.
Awesome.
Yeah, I was just saying I have done stuff with JavaScript, robotics, Java, yeah, a few things. So you're always welcome to reach out to me as well.
Really appreciate it.
Mike does a whole bunch of stuff relative to networking and stuff of that type of thing. If there anybody else who has a specialty that they like to put their name out there that people can latch on to you. I know Greg Smith over at West Salem does phenomenal. He does Java and all AP Java and stuff, and then same robotics up to Vex and stuff. And I've been a judge of his competitions over there. He's a really, really good teacher. So that's another source for people in those domains. You better get a hold of him quick, because he's getting old too, so I'm not sure how much longer he'll be around. So,
Getting old by the minute.
here,
Can I get this one
and
side?
Nikos did, I don't know what Nikos has been teaching well. I wasn't sure yesterday after our conversation, Nikos, whether in those years you've been doing math all the time or just CS, but I know there's several people that have been doing stuff at different levels. So touch base with each other, and you know, you don't need to pay attention to me. You can do messaging back and forth and look like you can earn your whatever they are called nowadays. You know, Kathy will give them to you. She doesn't know what's going on, so that's all right. So yeah, there we go.
So Don, I have a comment about Google Docs.
Oh, yeah.
So I don't know if you guys, I've never used it before. But yesterday I noticed that I opened up one of Don's programs and I wanted to copy the text into my, I'm using Idle like Don is, but I couldn't copy it. It lets me highlight it, but it never lets me copy it. So there's a little button at the top that asks you what you want to open it in. And I opened it in the text editor. But then when you first do that, you have to agree to Google's terms before you can utilize it. But once you open stuff in that, then you have all the doc procedures that you can use. So you
Right,
can copy and paste.
Depending on what you're on, and I think you are a Linux guy from what I'm listening to.
Yeah.
And I know on the Chromebooks and things, you can't use file copy. You have to use Control-C, Control-V when you're in the Google Docs, and that should copy paste. I went paperless 2 years ago in my classroom, and I used nothing but Google Classroom and Google Docs and things. So yeah, if you have questions, let me know, and I'll see if I can answer those.
Yeah, Michael, do you open documents with the .py file, or do you have to copy the text? Because you could download them.
Yeah, you can just do that. All I wanted was just the text. I don't like to clutter my thing with stuff I'm not going to use. So I just wanted the text so I could test it and play with it like Don was showing yesterday. But I couldn't get the text. So as he was playing with it, I couldn't participate because I had to figure that out. So yeah, I guess I could just download.
And if you go to the file, there's the code section. They have the PY versions, exactly, versus the document section has the text versions of those. I tend to do that just because when I'm in a group setting, if we were like at Wilsonville, I do print hard copy out of the code so people can write notes on it all over the place, and for that purpose. But here we're in a different environment, so whatever works for you. Okay, all right, let's kick into material stuff today. If you printed out or you're looking at, and I'll put it on the screen actually, mine, if you are the outline stuff that I talked about, the intermediate outline. And is everybody there now? Are we looking at that? So, Michael, thumb up for me.
Yes, beautiful. It's a beautiful thing.
Seen the outline?
Yep.
Yeah.
Good.
Looks good.
So if we look down in the first section, like I said, the key phrase I'm going to use, algorithm. Many textbooks, I actually agree with them. One of the things are, metaphorically speaking, is that what we need to do is all our students need to develop their own toolkit to be able to grab onto something, but grab onto the appropriate tool to solve the problem. And we don't do that very well when we have a lot of stuff. In mathematics, we do it too much. We say, here's the 5 steps to solve linear equations. That's one reason why I like geometry so much more than algebra, is because there isn't like 5 steps. You have to think and do stuff, but there are attack plans you can give and teach. And our books are usually pretty crappy at that too. So what we want them to do is develop algorithms so that no matter what level they are, I don't care whether they're doing intro stuff or we're doing advanced dynamic data structures or advanced other material, that they can look at a component, a piece of a problem and say, aha, what tool do I need to solve this problem with? And we need to literally teach that and embed that. Like I said, I'm not recommending it at all, but one of the benefits of correcting tons and tons, literally thousands of AP test questions from students is I saw kind of inside their brains and what was going on. And kids really don't have a grasp of how to pick the easiest, most efficient tool for a task. And And therefore, that's because most textbooks or most teachers don't do that. And I think that's really insanely important. So back to our constructs, I'm going to get through this and get past, we'll get through it as quickly as you guys want today. As you look at that outline, the algorithms that we need to do are, first of all, you need to say, like we did last week, is there something being done over and over and over? I.e., is there redundancy? If I start writing the code out, if I'm writing this piece of the puzzle more than once or twice, then I need to have a loop structure. But the thing is, I need to know which loop is most appropriate.
Hey, Don.
Yes.
Sorry to interrupt, but is there something different going on with your audio today? It's not as clear as it has been in past days.
That's interesting.
Ooh, is that anybody else besides Kat? Because I've got him loud and clear in my headphones. Anyone else?
Yeah, it's
Jen, Ranjani, Volner.
Yeah, it sounds pretty garbled on my end.
It's a little, just a little
It's garbled
quieter on
out for
my
me,
end.
and sometimes I can't understand him.
Okay. Now, is that
Sometimes I
better?
can't understand you.
Is that better now or not?
No,
Not significantly.
I know what may be happening. Let me change. I've got two cameras going here. Maybe they got the wrong. I'll see if I get the right mic here in a second here.
A good interruption, Kat. Thank you.
Yeah. I'll have to see this if this can do that. I'll change mics here. Maybe this will be better. Okay.
Are you
sound to
actually
me
telling?
like your
Go, Mike.
no, you just sound to me like your volume is low.
Are you asking Kirkwood to talk louder?
Yeah, same here. Volume's
I
low.
just strange brain.
That does sound kind of weird, doesn't it,
Yes,
Captain?
I know.
Oh,
Smart
no.
mouth. Hey. Let's have some respect here, guys. Yeah, right. I'm going to get off the share for a second so I can see my screen here a bit. Let me see this. Let me just check my plan this game here a little bit here. Let's see what I can do here.
Oh, this is a good. Kat says Don seems quieter today. That's never a good thing. I've never
Oh,
known
thank you.
Kirkwood to be
I like
quiet.
that. Hey. The smart mouth people are on here anyway. Okay. All right, let me
the
see.
classroom when he's quiet. You have to start worrying.
Right, exactly. I'm calling the EMTs if we don't get that fixed really fast.
Now, are you hearing me better at all now or not?
No.
No?
Ooh.
Okay. Oh, well, we will try little things more here. I'm just trying to play here. Okay.
I wonder where the microphone on his computer is.
I have two computers and stuff here. I mean, two cams, and they both have mics, and so I will see what's going on here. That's really weird because I haven't done anything different that I know of here. Okay. I will stop this. I will try this, and we'll see what goes on.
Oh, that's better.
Is that better?
It is on mine.
Is everybody else a little bit better here, perhaps?
It's
Okay.
louder.
I'm seeing heads nod. Why? Let's
Yeah.
go back.
I'm hearing feedback from somebody, but I think it's when somebody else has their microphone open and has it like on speakers
Okay.
instead of headphones.
I'm listening to you guys. I'm listening to your head shake. So here we go. So that must be we're getting there. All right. Okay. And do you guys? I kind of like this view better because I see your faces, but then you're not sharing my screen with the outline. But are you able to get the outline independent of the screen? Most people, because if you are, then I like this better than me blocking my screen with seeing just the outline. So okay. So the algorithms we talked about, the loops, we started discussing that the other day. I want to make sure we got it, but I want to go as quickly as possible without blowing everybody out of the water. And we've got to realize that there are radically two different or multiple perspectives going on right at this point in time. So I hope we'll meet a nice median, put it that way. So how did we choose? So the problems, here let's just use concrete problems. I always think that's better. If I roll the dice until I get a 7, do I need a loop? If I'm going to roll a dice until I get a 7, do I need a loop? I need
Yep.
feedback, guys. At least head shaking.
Yes,
It's not
you do.
de-mic yourself and talk. So yes. All right. Now, what type of loop? Is it a for loop or is it not a for loop?
It's not a for loop.
Not a for loop, while loop.
Be more careful. Yeah, because
Yeah,
We
but
don't
in
know when we're going to be
condition-
done.
We
Not
don't
how
know
many
how many
times.
times, before we start the process, I do not know how many times it's going to be. That's the key. When I get to the loop, I'm not sure how many times it's going to be. So it's an unknown number of times through this loop that I'm going to do. Yeah, like,
So I remember either hearing from you probably or reading it in the programming in the actual constructs. There's only a while loop, right? I mean, there isn't even a for loop.
what do you mean internally?
I don't know how to word it.
Actually, inside the compiler, yeah, in reality, they are all working the same way. That a for loop is a while loop, but
Yeah.
syntactically, readability, and all those other things, it's not. I mean, so we're just talking about kids coding and learning it that way. I think that's the focus is more important that way.
Yeah,
Because,
I just had that. I thought
yeah.
I'd read that and I had that question to ask you.
Yes, internally, in all honesty, it's the same loop structure, but the
Don?
fact that when we look at the code, it's not. Yeah.
So Don, I tend to think of it, and maybe this is too reductionist, but I tend to think of it as two kinds of loops. One is sort of an enumerative loop, and the other is a conditional loop.
Yep.
And conditional could also include while, or it could include some
Yeah.
sort of flag, like do this and I'll stop or whatever.
Yeah.
And the
Yeah.
enumerative is the for loop, which is do it these many number of times.
Exactly.
Yeah.
And I think whatever verbiage, once again, this is where our personalities come into our relationships with the kids. The key is, it's not for us. The key is for the kids. So I've got to figure out what jargon, what terminology is going to stick in their heads. And you have different students than I have. I mean, mine were North High, but mine were freshmen, some of them, but they also had a prerequisite of Algebra 1, completion of Algebra 1. So that's the population that I worked with, and therefore my jargon and my material went with that. If you at higher level, I know several friends of mine who teach at real high level private academies, you know, the kids, everybody gets to calculus by their sophomore year of high school. Well, then that's a whole different population, and therefore my jargon can be different than that. So you just pick, and if you're middle school, it's a whole different beast, right? There we go. So whatever you're going to use, but we separate those two, whether we know the number of times or we don't know. I always say known number, for loop. Unknown number, not a for loop. And the difference is on the second category, unknown number. In reality, other languages, C++ and Java, have three looping structures. A do while or a while, or a repeat until back in the old Pascal days. And in all honesty, those have a huge benefit to them syntactically. The pattern, the algorithm is cleaner. Python does not. You have a while loop. But the fact is that there's still two types of while loop syntactically. The algorithm, there are two versions of it. And like I said, as someone who's corrected, I hate doing it, but the benefit is correcting all those tests, you kind of get inside to see what's going on inside of students' heads. And they really don't grasp the difference. A huge percentage of kids make stupid mistakes and or work way too hard. And so my job, when I saw that, when I started seeing this happening, I said, I got to teach different. I got to make sure my kids don't have that problem. And so therefore in the while loop, there's two types. One version was what we just said, input, roll the dice 100, you roll the dice until you get a 7. The other type is what we talked about last week, which was I have an unknown number of students and I want to know what the average test score was. Now, why are those two different? Both of those are not for loops because
They're conditional.
they're conditional, right? And for some of you, though, that's true. And for us intellectually, and that's the way most textbooks would describe it, what you said, that was perfect. For my students, that's a piece of it's more than 2-syllable words, so that ain't going to stick with them very well, personally. But whatever works for you. But that's what it is. They're conditional. But they are different from each other. Now, how are they different from each other? Roll the dice until you get a 7 versus I have an unknown number of students and I'll put the average test score.
The chance element in the die roll?
Probability, yeah, in all honesty, huge portion of the category I'm talking has to do with probability, but I could be saying, oh, good, here's another, I like that, that's what I want to do. If you've seen this, and this is a cool problem, some of you who, and several of you alluded to that this is a little, like, you talk to me individually, otherwise that you were hoping we were going to move along at a little faster pace. I hope so, kind of, but that's not the point. But you could do some stuff on the side. For instance, the Euclidean algorithm for greatest common factor is a phenomenal, really cool algorithm. And I don't know if you've ever done it. It's a whole lot better than the way we teach it in mathematics class, I'll be honest with you. I taught it to our sons when they were in 3rd grade and they loved it. And it was really cool. So what the idea is, you've got a piece of scratch paper, here we go. You can just do this. Euclid, and I love it that you could claim up with this a year or two before computers were designed, just a year or two. And so it's slick that it came out to be. But the idea it comes out to be is that you have two numbers, like 8 and 45, or 8 and 40. Let's just do that. 8 and 40 is short and sweet. So you take 8 and you divide it into 40. All right, maybe I'll go here. That should take me to the other camera. Did it do it? No, it didn't. It didn't. Oh, maybe I did it that way. There we go. If you have 8 and 40, you divide 8 goes into 40 how many times? It goes 5 times with 0 remainder. Therefore, guess what? 8 was the greatest common factor. Now, by the way, is this redundant or is this new to many of you? All know it or you don't know it?
I know greatest common factor, but I'm not sure if I.
Okay, so this was real easy, but what happens if it's not so slick? What if we have the greatest common factor between 8 and 26? All right, so you go 8 and the 26. You go 3 times 24. The remainder is not 0. Therefore, what we do is we take that remainder and we go into the old divisor. 8 divided into 2. 8 divided into 2 4 times. 0 remainder. Therefore, the greatest common factor was 2. So you keep doing this transition where you do the division, find the remainder. If the remainder is not 0, you then use it as a divisor and take the old divisor and becomes dividend inside and we do it again.
Is that weird term they called the modulo or whatever? I was reading.
I was just going to say, if you need to deal to get this remainder. We actually don't need to do all that division garbage. We use mod, and you use the mod. And if you look at your Python help sheets, on those help sheets that I gave you, both the intro and the intermediate class, it has got those pieces of syntax, and that is where we would do the operators. That's what we would do the earlier on when we did linear constructs. We would have done a whole mess of those problems if this was an actual course with kids.
Okay, because yeah, I was reading that, and that whole term didn't make sense to me until you just put up on the board, and okay, it's the remainder thing.
Yeah,
so
there we go.
I didn't connect the two.
Yeah, and reality, what's phenomenal to me, matter of fact, I tell my kids this, if you're solving a problem and it has to do with mathematics, and it's really easy for you to do, but you can't figure out how to get the computer to do, it is unbelievable. It's like 80% of the problems that I give the kids all the way through 4 years of computer, 80% of the time when they have that type of an issue, the answer is mod. It's insane. Mod solves things that I would have never thought of solving. Some of you might want to mess with that and discover what's going on. Now, right now, most of you could not code that, and that's cool. I don't care about that. Those of you got coding, and some of this is redundant, do it. It's kind of a fun algorithm. All I'm doing is an example to say the following. That process, Euclidean algorithm, is it a loop? Do I need a loop for that to solve that problem? I'll think about going, if you get some really weird one like 26 and 84, you may have to do this several times before we get down to it. I picked some nice easy ones here, right? So the answer is yes, I need a loop. But this is a for loop. Do you know how many times I'm going to do this process? No, right? Therefore, it is an unknown number. Now, here we go. Is that example more like the rolling the dice until we get a 7, or is it more like give me an unknown number of test scores and I'll put the average?
feels like the dice situation.
Like dice, isn't it? And Rajani, that's why I brought it up, because there are examples of this that are not probability, and that's why I came up with this one.
Right, and so you're basically going to do this until mod whatever number equals 0,
And
right?
then, yep, and then your divisor was your answer.
Okay.
Now, isn't the Euclid algorithm one that can be done recursively?
Oh yes. Matter of fact, any loop can be done recursively. Any loop. Is it best to, now, if we get into this and we get to that stage, we'll do recursion here as a discussion. I would love that, because frequently we choose recursion when it's not appropriate, but people don't know that. They don't know when it's best to once again, it's an algorithm, but when is it best to pick up that tool? You're exactly right. Actually, this is one of the tools we use to teach recursion when it's intro. And then we say, why is it not best to use recursion on the solution? Because there's a real easy one iteratively. So now, how do I split this? Unknown number, guys, right? Do you see what I'm trying to get you guys to do? Is I want to think like one of my students. I've got to teach in a way that any of my students in my classroom, if they want to, and put forth the effort, can grab onto this in any way they want. I don't care their jargon, I don't care their terminology they use, but I want to set them up so that they can, I call it a sieve. You throw a problem into a sieve, you shake it up, certain things fall through. Is it a loop? Yes. I put it in again. What type of loop? Do I know the number of times? Yes, I'm done. I don't need to do it anymore. I go. If it's not a known number, how do I separate these two? How can I verbalize the difference between rolling the dice 7 times, rolling the dice until I get a 7, and the Euclidean algorithm versus an unknown number of scores, or the file stuff that Jetson alluded to, because almost all file structures are of that nature too, right? Because I don't know how many elements are in the file, but it depends on how you verbalize it. It can be, because I know when it's going to end. If it's an ended file marker, I know that. So that's more like the random dice stuff, right? There are 2 different types of problems. How do I delineate that? How do I separate so that I clarify for my students? Now, by the way, in my class, I just throw out tons of problems. We keep throwing out problems just like this. We're not solving them. I'm just throwing them out. I keep throwing them out and throwing them out and throwing them out until the kids start categorizing them and going this, and then they come up with, all these problems are this. And like I said, teaching a geometry class and letting the kids come up with all the proofs for the triangles is so much more effective than them memorizing some stupid name that somebody gave in some textbook. They remember it. Here's the same thing. So what would you guys verbalize? How would your kids separate between the randoms and the Euclidean algorithm, all that stuff, versus the unknown number of scores, or unknown number of customers coming in my store, or unknown number of cars being sold, right? How do I verbalize that these are the 2 categories of problems that are unknown numbers?
Could you repeat that, please?
Okay, perfect. And let's backtrack since we've done this. In a textbook, what would they do? They would just throw problems at kids and say, just keep practicing and solving them and you'll get it. No, that's not teaching. If I want, that's imparting information. So here, once I teach, if they know the number, done, for them. If it's an unknown number, and we verbalize it, we verbalize the following in one group, kind of. Rolling the dice until I get a 7. The Euclidean algorithm goes until we get the 0 remainder. We got that. A file structure would go until we get into file marker. We got that. Almost all random ones fit into this. On another group was, I've got an unknown number of test scores, tell me the average. I've got an unknown numbers of customers coming into my store today, tell me my profit. I'm selling cars at my car lot, tell me how many cars I sold today. Can you see how those 3 problems are different from the problems that I gave with the random Euclidean algorithm? They are a different beast. Do you see that? Does that make sense?
Yes.
First of all, so we have to see that. And now what I'm saying is, Tell me the difference. Describe the difference. So I have like two little titles that I can put up here. Difference between a linear equation and a quadratic equation. We know what that is. But what is going on here? Because the syntax is different. The semantics is different.
How do you want us to describe the difference? I mean, do you want us to tell you how we would write the code differently?
No, I want a good point. I would like a title or a descriptor. All right, let's backtrack again. For my problem, we get doing it this way, and it's so different than doing it face to face, but here we go. I want to be able to teach my kids when they look at a problem. So let's backtrack the end result, right? We have a test. My kids look at a test over looping constructs. I want them to be able to look at that test and read every problem and be able to say, aha, this is this, therefore it works this way. That's what I want them to be able to do. So they're confident, correct? And so I want to have a category, some verbiage.
I've got an idea.
Standards. Yeah, got it.
Input randomness, output randomness.
Okay.
I don't know if that makes, okay. So I guess what I'm trying to figure out is I'm trying to figure out a way to differentiate the random sort of a roll a dice until you get a number versus you're inputting a certain unknown number of times. So the inputting a certain number of unknown times would be input randomness, and the rolling until you get a certain conclusion to the loop would be output randomness, even though that doesn't really necessarily work. I'm stealing from board gaming.
Yeah. Well, and by the way, what we're doing is, you see, this is not easy. It wasn't, I know it took me several years to come up, number one, to realize there was a problem. Number two, to come up with some jargon that I thought fit, that was easy for my kids to put a hanger. I want 3 hangers in their brain. So whenever they get a problem, they go, it's this hanger. I know what to do with this thing. I don't want them to have to reinvent the wheel every time they read a problem. I don't want them to have to rethink, how do I attack this thing? I want them to go, this is what we do. Cool. I feel confident. Let me solve the hard part. This is the easy part.
So, Don, a couple of words and analogies come to mind. One is sequential and linear is what comes to mind when you're talking about do all these till they hit a space bar, as opposed to this, the Euclidean algorithm. It feels a little bit like you're either asking me to go from store to store to store and do something, or you're asking me to go to the post office, and the post office is a special riddle, and then I solve it, and then I end up in the gallery, and then when I solve it. So I'm kind of darting around in a non-linear way to get to the goal. So linear versus non-linear, maybe?
Yeah. And what I'm showing you guys today is what I think, and this is why it's so much harder. This is why textbooks suck at this, is because this is teaching. What we're doing right now, what we're thinking through, is what teaching is, not imparting information. Imparting information is what it is, but that's not teaching. And if we teach, our kids will be radically more successful because they'll be having fun. They'll be having fun doing this. So I'm going to give what my answer is, and you could say, oh, that sucks, and come up with your own. That's cool. I would love it. I would love someone to tell me better. I steal all my answers from my students frequently. I came up with the following. These are both unknown. I looked at what made us quit. To me, the key differentiation between these two things was what made us stop this loop. A for loop, I know the number of times. That's telling me I'm going to do it 8 times, done. The one loop was when I got to a 0, when I got to a 7, when I rolled doubles, and that was something that will happen naturally. If I'm playing this game or doing this math thing, the answer will happen on its own. The user doesn't have to do squat to make that occur. It will happen in the sequence of events. That's kind of what you're talking about, the randomness. So I said, if it is a natural flag, what tells me to quit? That's what I call a flag. What tells me to quit is a natural flag. When I read the problem, it tells me when I'm going to quit the sucker. When I do the hands-on when I did the hands-on up on the board for Euclidean algorithm, you knew immediately when it got to 0 for the remainder, that's when I was going to quit. And that is going to happen sometime, even if they're relatively prime, because it'll come down to greatest common factor of 1, and that will produce 0 as a remainder. So from what I came up with is, if it's a natural ticker, a natural exiting condition, and I use the term natural flag, it is the 1 category. If it is an artificial flag, we use the other category. Because do I know what value is going to make me stop when I do an unknown number of test scores? No, I don't. There's no. So remember we talked about this last. We would pick -1, or we would pick 999, or we pick something. Do I know who my last customer is going to be coming to my store? No, I don't. So I'm going to have to use some value that says the day's over, lock the door. But I have to tell the user what that value is. I have to say, please type -1 when you are finished, or type 999, or type space, right? I have to tell them that. Notice what we're doing. If we categorize them this way, it's also kind of bringing out with it the syntax that is going to be the solution partially along the way also. You see what I'm trying to get to? It does both for me. So therefore, I now have 3-type loop. For loop, as soon as I know how many times it's going to be, sieve off, done, for loop, I know how to do it. Second, if it slides to that sieve, it's an unknown number of times. Therefore, do I know when I'm going to quit? Does the problem tell me when I'm going to quit? If it does, it's going to be a natural flag, and I'm going to do that organization. If it is an artificial flag, I'm going to do this organization. Now, are those great terms? No. Could you come up with better? I hope so. Please tell me. I will use it and steal it from now on out. I'll put a little TM on the bottom of it and put your name on it somehow. Here we go. I have no problem with that. You'll see a problem later on if we get to it. I literally did that. I stole the guy's program from Wilsonville because it was better than my example, and I his code. So he will live on in fame or infamy, depending on what we get to that problem. So that's my organization. Please, if you come up with better, please let me know, and we'll steal it. All right? Now, we spent a bunch of time doing that now with this example on a simple one, because what we just did is what I think we as teachers need to do. That's the difference between textbooks and online coding versus you and me with a classroom setting. The two of us can look at our kids and see what's going on and know where they are, their background, and I can explain things in a way until I see that light turn on in their eye. I can see them getting this now. And if we can get to that stage, I ain't going to be worried about them copying and cheating and doing all that stuff, because they're having too much fun solving these problems on their own versus just getting the stupid homework done. It will take them longer to go out and search and find a stupid answer to copy than it is to sit and have the fun of figuring out how to do this problem. That's what I want my kids to be doing. And that's how they'll stick with me. Now, think about it. Judson, you were 3 years, weren't you? I think, or maybe you did. I mean, you have to be. You guys only have to be 8 hours. Think about idiots who choose to be with me for 4 years. There's got to be something external. I mean, you got all this other negative crap, so you've got to be having fun some other way to make it worthwhile. And that's what I think we can do. So that's.
Hey, Don. I had an experience in kids working with the while and the for loops, you know, because you can write one to be the other. You can convert a for loop into a while loop and vice versa. And I went through, you know, the discussion about how you use a for loop when you know how many times, and the while loop when you don't know the ending point. And what I found was kids really felt a whole lot more comfortable with for loops because they seemed to gravitate to them for some reason. And then what they would do is they would put a break command in the for loop, and it would just drive me crazy. So
I just take out points. Done. If they want to do that, I just take out, because I can show them a more efficient way of doing it. I can show them how the code can be written better, time-wise and efficiency-wise, and that's what matters. And so you're 100% right, Charlie, but the fact come out to be is when I looked at over and over and over on tests, they would do exit or break at the wrong place in the wrong time and using it in the wrong way. And I would love to set them up on brick walls. I have students who do that, so I would make a problem that would nail them. And you're going to see one coming up in a little bit. I would just love doing that, just because I would love to say, oh, you mean that approach that I told you is not best didn't work for you? Oh, what a shame. What a heartbreaker. Well, you know, that's a killer. I feel, my wife, elementary teacher, I feel bad for you, or something like that. It was like, yeah, there we go. Yeah. But the fact comes out to be is that later on, then Charlie, you're right. We've got to figure out some way for them to see it as quickly as possible so they don't get the bad habits. In here, if we do that though, that part of the reason is because we didn't give them a tool for the other one. We just do a bunch, the book just throws them 95 examples and says now code, rather than helping them build a framework for it. If you look at the outline, I've got the framework for the one. I really love if we have a language that has the do while loop or the repeat until loop, because then it's got a real simple, compact, efficient piece of syntax that solves those natural flags. There is a way to do the exact same thing with the while loop, but it's a little bit more tedious. And that's why I think it's stupid that Python threw away that option. I thought it was a waste of good potential for two pieces of syntax.
Hey, Don.
Yeah.
So what is your philosophy, or how do you approach commenting as a way for students to justify the algorithms? Or do you just have them explain it verbally to you? Or so I guess what level do you require them to comment their code? Obviously, you don't want them learning to comment every single line because that's inefficient. But when do you start that process, I guess?
To me personally, it's a little later than this. I always said to kids in the very beginning, anytime I do something a little quirky, the comment at the beginning is for them. I say, if you're smart, if you were in English class, I say, you wanted to be really smart, write great papers in your English classes now and keep them. Because when you go to university, if you wrote a really good paper in high school, that ain't cheating to pull that sucker back out, revise it a little bit, and turn it back in. If it is a good paper in the first place. Smart and Lazy says, do what's right in the beginning, and you can reuse this in the future. In coding, I say the same thing. Your guy's going to be going, and I pull off problems from former students and come back and say, this is their test that so-and-so took at U of O or OSU and their CS 261 class. Here it is. Well, guess what? We're going to be doing 3 of these problems now. These are your homework going to be this chapter. If you write this code well, this is going to be great. So, but I say 2 things. Number 1, for you in the future, if there's something you had to stop and think about, then comment it. Because 3 years from now, you're going to not remember what you did at all. 2, I've done this once or twice or 5,000 times. If you make me slow down to read your code to figure out what you're doing, especially if it's right and it's tricky, you want to brag about it. Or if it's bad and stuff, you better be justifying your answer, because I'm going to be with my little teeny red pen. You slowing me down. I have to correct 8 periods, 7 periods of 30 codes each, and you are slowing me down, so you're ticking me off. So unless you give me a real good description, I'm going to look for ways to take points off from you. So a comment would be that exact process. I'll go, oh, this is really slick, or no, this sucks, and here we go. So I guess that's when I do that, is that if you had to think about the solution, you better comment it for you and for me. At this stage, that's where I am. Later on, when we do teams, we add another layer to that. But at this stage, that's where we are. And also that is internal documentation. You pick good variables, because if you pick good variables, I can read your code. Like I said the other day, I don't know, this class, the other one, you should be able to hand your program to your parents if they are good at math or whatever the subject and code is, and they should be able to read it. They wouldn't code it, but they should be able to read this and understand your solution because you chose good variables that have meaning to them. So those are the 2 sort of process, personally.
You know, I was looking into this, Don, because I was working on an assignment for my robotics class and I wanted to really focus on commenting. And so I was looking for a video to talk about good ways to comment. And YouTube is positively full of suggestions on when not to comment. Like, they're very concerned about people over commenting code. And I don't know how to balance that with the obvious, like, explaining to them that in an educational setting, the commenting might be very different than in a professional setting. And obviously, like, your own fluency and understanding of the language impacts your commenting as well. So I don't know if you can address that at all.
But I think once again, it depends on your level and the process itself. When you work as teams, then all of a sudden commenting has a different meaning to it because we have to deal with this stuff when you're, but I think the complexity of the code really makes a difference as we go up. And that's when we'll pull it off individually. By the way, the university exam was one of the biggest problems. Two levels that I don't do at high school. One is the level of math and the problems, although we get pretty good, but level of math and problems in college, especially with college professors, to stick all this math crap because that's the easiest problem to give to the students because that's what they know. And two is commenting. They will, it has to be a third of the code, and that's because they have a graduate TA correcting their programs and they don't ever look at the code because it's unreadable. Students send me back codes and they say, Kirkwood, this is my first program. It worked perfect. It's really cool, but I got a B because I didn't have enough commenting on it. So the next one I did this and I got an A, and I looked at it and went, my God, I can't even read. I can't find your code in this. And that's because the professor didn't give a rip. They didn't ever grade them. They had the TA do it, or they just ran the code and said, yep, it worked great. Enough comments? Yeah. I mean, that's the difference until you're a professional. And bringing somebody in from industry to talk about that may be the solution for that, depending on what level you're at. I know that's what I did with mine sometimes at the advanced classes. Judson, you were going to say something?
Concerning comments, I generally tell my students that there's really two places where I want to see comments. One is at the top of the file describing what the purpose of the program's for, and then the second one is before every single function, outlining what the function is for as well as what the function needs in order to be used, just to make it really clear. But that really only plays a part if you do a lot of function programming. And I try and teach functions as early as possible.
And if we got
one other idea is to maybe lump a bunch of things into one. So suppose your project is for 7 points and you do this, that, and the other, and you get 5 points. Let's make 2 points. Let's give 2 points for not just documentation, but also sensible variable names. And then whatever else, like formatting, having good style, that kind of stuff. So if you don't have those things, then you earn a B, otherwise you get an A.
And I know I keep coming back to this, but it's just my experience. It's not like I'm recommending this. But one of the cool things about the AP response, free response question is as Judson alluded to, every single module, which is what you write, is commented. And if you are really smart and you understand how to use comments, you can read those comments and not read anything else on the entire 3 pages leading up to this question, because the rule was when on the committee, whenever we made a function, everything that was essential for that function to work and work correctly had to be declared in its comment preceding that function, which is a professional model for commenting, just as Judson was alluding to. Therefore, if you learn to do that and you read them, it made the test insanely quicker to take because you just made sure it followed all these parameters, did those input and output structures the way it said in the comments, and you aced it, and you didn't need to read the 4 pages ahead of that unless you didn't understand what this meant, and then you went back and looked at the example. So that is the way good comments should be done, is it does exactly that. Anybody can steal that, read what the comments are, and know exactly what's inputted, how it's doing the job, and what's going to be outputted. All right, now, by the way, this is all I was telling somebody else, I think Kathy, we were just talking about that before we did, T and Kathy, that where this thing goes is nowhere where I think it's going to go, which is perfect because this is your class. This is cool. I had no concept that we were going to deal with this. All right, Michael, what do you got? Mike, did you have something you want to share or not? I thought I saw a hand up. Oh, I thought maybe it was just scratching your head. Okay, here we go. All right, back to the algorithm stuff then. In this stuff, there is a distinct algorithm. If you look at the outline, and the kids, this is the algorithm for an artificial flag. If you look at it, it's G12B. There we go, the artificial flag algorithm. And what I have the kids do is we build this and test it. We did this kind of the other day a little bit, but the idea comes out to be it will work this way always. If they separate their parameter, their puzzle pieces into for loop, unknown number, aha, this is an artificial flag, I have to tell the user how to do this. That second category, which is where, by the way, students screw up the most. That is the most frequently messed up problem on AP tests of any piece of the puzzle. I don't care how level the AP test, I don't care if it's AB level, that's still the most points taken off in every exam, other than leaving the question blank. And if you look at the outline, you have to get the flag variable. So if it was scores, the variable I'm going to use to quit is a score. And when the flag variable score doesn't equal the flag, -1 or whatever we do it, while that is not there, we go into the loop and we do the process. We do this stuff and we have to get the flag variable again. What's cool is that short, sweet, easy with the class. We prove it. Everybody says, holy Kirkwood, that's inefficient. We go through all their possibilities and we show to them, this is the way. Actually, I usually let them come up with their ideas and we either discount or prove their ideas until we get to this, if I'm actually in the classroom setting. On the A, the natural flag, if we have another language that has the do loop or the repeat until loop, I teach that and it's perfect. If it is Python with a natural flag, the only difference comes out to be is that we have to initialize like the rolling the dice. So what is the rolling of the dice going to look like? If you guys, well, let me just talk it through. If we roll the dice, to get into the loop, right? Notice there's another big difference. The artificial flag may not go at all. You may not have any customers at your auto store today. There may not be anybody there at all. Whereas if you're rolling the dice or you're doing greatest common factor or you're doing, you got to do the process at least once. There's no option, there's no choice. So what you do is you initialize the flag like the dice, you say dice is 0, while dice doesn't equal 7. All right, we're going to roll the dice until we get 7. And then what do we do inside that? We do the process. So we roll the dice. And then we go back through the process again. Notice frequently there is no input from the user on the natural flag because the process is going to exit on its own through some natural process. And a user innately is an artificial piece of the puzzle, right? So therefore, that's the loop structure we have. That's different. If they, especially this artificial flag, if they get that down, they will make so many fewer stupid mistakes and work so much less. Just because you pull up a hammer, and this is the hammer, there we go. This is how it works. Done. Now we got it. Questions? I like to actually a big discussion about the pedagogy here is the key to what's going on. I'll be honest with you, that's the difference between you and some canned piece of software that costs a whole lot of money. It's funny how they'll spend that money for that software, but not for you to be in service. But that's another whole issue, but that's okay. Effectively in service, I should say. Ineffectively in service, they'll pay a whole lot of money for that, but not effectively in service.
So Don, the program is 5 well random. I don't know if you want us to look at the program at all, but it is number 5 well random. The when while roll does not equal 7.
Yep.
If anyone wanted to see.
Yeah, that one you can look at. And if you have the printout of the code, we've got it all here. Yep. While random, it's number 5 there. And I've got different loops here. I've got different places. I've got my file at a different location right now. Sorry. Yeah, we have the code over here. We'll pull that up.
Is there a reason that the variables are called twice in this program?
Planks?
The variables roll and count are both in and outside the while loop. I'm guessing just so you could recall them.
Okay, just a second here. Let me get out of here and get to the right screen so I can do this thing. Okay, so you were talking about, make sure we're talking about the same one. You're talking about that code. I'll pop it up here. I'll show it in a second here. Google Docs is taking its time. How nice. Come on, you everybody. Is this the one you're talking about?
It is indeed.
Yep. All right. So now what was your question based on that?
Oh, I just noticed that you called count and roll both inside and outside the while block.
Yeah. Well, yeah, good. Is this the efficient way of doing this? That's what the question comes out to be.
I wonder.
Okay. This is what some students will do, and it is okay, actually, it will work. What ends up doing, especially with the GCF, we have an issue with it. It's stronger with that. In all honesty, if you had done this, because if you'll note, we had a lot of redundancy, and actually I was going to set this up exactly what you're talking about and say, holy, can we write this more efficiently? What we had written it as is an artificial flag, but hold it. Notice if we wrote it as a natural flag, the algorithm was to initialize, right? Notice, look, all I'm doing is deleting a whole bunch of lines of code. If it's a natural flag, look at the way this works, right? Now, will this work the same way? And the answer is, yep, this does the job, isn't it? Is everybody seeing the loop and stuff that I've got going here now?
Definitely.
So notice, if we had done it just like the standard while loop process, the way most kids would have, if I hadn't taught them two versions, it would have been the version that we had online. And that's the one I was going to be sitting there talking to if we went code by code. If I now change this to what our discussion has just finished and said, this is a natural flag, therefore all I need to do is set up everything, initialize everything, and then run the loop. Notice it's a lot less code because there is no user input. There's no need to do stuff before the loop. It's got to run the loop once, so let's do the stuff inside the loop. Make sense or not?
Yeah, that makes sense to me, Don.
Yeah, I'm not seeing faces, guys, because I'm sharing screen, so so I need to have some feedback. That's my point. Exactly right, Kat. See, this approach is cleaner, easier, and guess what? GCF and randoms and all those codes can be done like this, versus the artificial flag has to be done with getting the stuff before the loop and doing that process. And if I don't delineate between those two tools, kids will gravitate towards the one, or as was alluded to before, just do it in a for loop and do an exit or do some break or some stupid thing to get out of the puzzle in the wrong way. Spaghetti code back at old Apple Basic. Which really ages me. So
can you explain the artificial and natural flag again? Because to me, the flag is still roll not equal 7.
Yep. But okay, cool. And I'm going to stop my share. So I'm looking at your faces. You guys can look at that code, right? Because it's changed. I think if you're looking at the code, it's changed for you. It's not probably on your screen anymore. So here's the difference for me, for my verbalization. When we're reading a problem, that's where I want the kids to attack this. When they read a problem, they go, ha, do I need to loop? Yes, I'm doing something over and over and over again. First, do I know how many times? Yes, for loop, done. Do I not know how many times? Okay, I don't. But what tells me to quit? Is it a value that the problem hands me? Is it a 7 that I want to get to until I get to a 7, then I quit? I'm going to roll doubles. So when they both dice are the same, I quit. Or is it when I get the Euclidean algorithm says when I get a remainder of 0, I quit, i.e. something that will naturally happen without me doing something to say we're finished. I don't have to do squat. If I run my program, it does it all on its own. That's called a natural flag. The flag is what tells me to quit. This is the value that tells me to quit.
So this program has a natural flag.
Which is
the 7.
Perfect. Exactly.
Okay. But either way, like I see that the second way is more efficient. I like that way better.
Yep.
But in both cases, the natural flag is the 7, isn't it?
Oh, yeah. Oh, perfect. No, I was saying the other way was what, if I was a student personally, it's the way to use the artificial flag algorithm to solve all problems. And what you just said is perfect. That's exactly what I want them to see. I want them to say, aha, that I could do it, but it's stupid. It's inefficient both for the computer and for me. I don't like doing all this work. So exactly right, Kim. That's what I want them to get. Is what you just said is perfect.
Okay.
That's the brain switch I want to have happen. Exactly.
Okay. But this is cleaner because you're only calling roll equals random.randint once. You don't have to call it before the while loop starts. Okay.
It's more obvious. It more follows the flow of what we would do in real life. It's everything better.
Okay.
And the other one is when we have to do an artificial flag, getting it from the user. And we can go through that again if you want to or whatever, but it is the tightest, most compact version of that it can be. You can't tweak it in any other way without making it less efficient. And we can look at one if you want to. That has to be an artificial flag.
Don, I think there's also an interesting conversation to be had around how role is defined. Because I could imagine a kid saying, well, I'm just going to say set random.randint to 1 to 12 instead of doing 2, 1 to 6.
Well, we are skipping a whole bunch of steps here. You're 100% right. If this was a real course, we would be doing 6 or 8 or 10 problems all along the way. And random, the deal with probability is one of those issues. So we'll talk about that exactly. Correct. So yeah, we are, with this 8 hours of teaching an entire course in 8 hours, we are obviously skipping over a whole lot of puzzle pieces. Exactly. We hope to get the outside edges done in 4 weeks, maybe. Okay.
I have a quick question on that randint though. Isn't that just the number of numbers on a die?
Correct. Well, this way because it's 1 through 6. Correct. But the idea was you can't do one dice with 2 through 12 on it and have it produce the same results as 2 independent dice. It doesn't work that way. And you can play around with that and see that yourself. Yeah.
So Kat, was that what you were talking about?
Yeah, because the probability of 2 d6s is totally different from 1 d12 that's a 2 to 12 sided die.
Yeah. 7 is going to occur a whole lot more often than a 12.
Yes.
And the only way to do that is by having 2 independent dice. Yeah. Yeah, Michael.
Kat, I witnessed him one time. A kid actually asked that question, and he simply said, when you rolled your dice, what did it look like? And he said, well, it's 6 sides and it had 1 and 2, 3, 4, 5, 6. Oh, so, and then all of a sudden I heard Don say so, and then all of a sudden it was like from one kid to the next, they said, oh, we have to do it twice. And I thought that's all he did. That was all he had to do.
Well,
that's awesome.
We talked about hands-on and algorithm. You guys alluded to that stuff. Randoms are great for that because what we think frequently is not, the birthday problem is the biggest screw-up thing there is in the world relative to reality versus what we think. So, yeah. Plus, kids love to play games that way. Doing dice and graphics, any random stuff kids get into. It's fun.
Yep.
Okay. Questions? Okay. So on this stuff, the algorithms that you should go through as Kat has alluded to earlier with this random, we would have a whole bunch of problems and I would be having them solve several problems. What I like doing personally is, like I said before, when I give a homework assignment, they have to do, I give 3 problems. I call it A, B, and C problem. If you just barely got this or you don't have much time, you can solve the C problem. You get the exact same points as everybody else. You get 10 points out of 10 if it's right, but it's an easy one. If you want to do a little bit more challenges, B are the most challenging is the A. But if you take my test, after all doing C's, that's what you're going to get on the test. On the other hand, if you do all the A problems all the way along the way, my test is going to be a breeze and you're going to ace it without even breathing twice. So you have choice, because some days you have a harder day, sometimes all that stuff, and all of that's valid. I don't push you that way. But the cool thing is they all see 3 problems. Even if they aren't doing that as a homework, they have internalized 3 problems. I love subversive art of teaching. We can do this so much more than we think. We can really be twisted and actually make them learn what they don't even want to. Because if they just look at the 3 problems automatically, solutions are kind of evolving in their brain, which is perfect. That means by the time they take the test, they've done 15 problems, not 5. They've seen 15 of them. And whether they solve them all or not, there's pieces of that going around. So that is an approach to do it. So yes, we would do tons of problems with all these pieces of that puzzle involved there. I also do the very first problem. I do in almost everything. You'll see if you ask for my outline when we get this done and I get it formalized and get it really so it's readable by somebody else. My first problem in almost every new concept, and I don't know if I used to do this back in your day, Judson, I actually learned this, as the years went on, I actually, I learned new things. I hopefully got even better. But so one of the part, I hope I got better than when you were there. Yeah, we won't let you talk very much. I'll mute you automatically, Judson. So here we go. So, but the idea came out to be, as I always call it, the best effort problem later in my later years. That is the very first problem I give them on homework assignments. They get 10 out of 10 points if they do the problem. If they give me their best effort, i.e. they actually do the code and do it, I don't care if it's completely wrong. Matter of fact, it's almost better if I do get completely wrong answers. Because I'll ask them ahead of time, can I show this? And we'll use this as an example and say, this is really cool. This person was really attacking this and doing this. Does this work, or what does this produce? Also, by the way, as a person making the AP test, I would steal all those wrong answers because they would be the wrong answer on the multiple choice test questions. Or they would be the problem that says, what is the output of this problem, when it really isn't what people think it is. It was perfect. So smart and lazy, I stole stuff left and right. So therefore, that's what ends up happening. So those are the 2 types of things that will resolve this. So are there questions on summation, max, min, counting, averaging, sequencing? Sequencing means input numbers until one of them is less than the preceding one. We get a lot more with the sequencing when we get the lists, but in here we can do all those sorts of things. If not, we'll kind of move on and go to the next piece of the puzzle.
Don, I feel like showing an unnatural
to see one?
Yeah, to see one would be a really good idea.
Okay, all right.
Even as something as simple as
well, here's wild ad. Here we go. Yeah, good one here. An artificial or unnatural flag. Here's the wild ad, the straight calculating an average with an unknown number of items. Here's an age in this case. Are you guys, am I sharing that screen or not? I don't. Okay, I will do that real quick like. I didn't think I was. No, I was looking at your faces, so I couldn't. Here we go. Everybody seeing it now? Judson, have we seen it? Your face is the one I'm seeing. So thanks.
Definitely.
There is an artificial flag, right? And do you see what we got? We have get flag variable, wild flag variable doesn't equal the flag, do stuff, get flag variable again.
Something that I think is really important to understand, you guys notice that the age equals int line is both in the loop and outside of the loop. But notice it's not the entire content of what's inside of the loop that's also above the loop. It's only that one line. And that really is a good indicator that it's this special type of unnatural flag, is that it's not the entire thing that's in the loop that's also above the loop. It's just one or two lines.
Matter of fact, it can get more elaborate, as Justin alluded to. If you input a bunch of stuff, like input an unknown number of salaries and employee ID numbers, and then output the average salary of all and what employee number earned the highest salary and all the junk. We add a whole bunch of stuff to it. You notice, and I always tell my students, this unknown number is get flagged variable, not variables. You're trapping one variable almost all the time. So you have to choose what variable you are using as your flag. In this case, it would either be the employee ID name, a number, or the salary, not both. So you just get one variable outside the loop. So if I was doing age and ID here, if I like age and name, or I would do this. If I get my hands on the keyboard without looking at stuff. Oh, come on, Kirkwood. Notice the name input is not outside the loop because I'm using the age as my flag. The only flag variable I have is that. Now, do you understand why I wouldn't put the name? Why don't I? This seems stupid. Why don't I put this up here? That's where it belongs, isn't it? Doesn't it go with the age right there?
Frankly, I don't know why you would put it in the while loop either, because once you gather my name and you've taken my age, and then my name just vanishes, and then by the time the next person's name is entered, right?
Yeah, well, it would be for a different purpose. If I had asked, tell me who is the oldest. So get the average of the ages, and then also tell me who was the oldest. So it'd be a different problem. You're exactly right. So, but I'm alluding to the fact is if I have a loop, so if I did that, well, let's just talk about that now. If I ask who's the oldest, since it's max men, what would I do now? Let's just change this and we'll evaluate this thing. How would I calculate, this is doing the average kind of, but how would I figure out who was the oldest? What would I do also here?
Well, set an artificial old that's really low.
Okay, so for max men, you have two different things. One is I can set and say oldest, old equals that age we've got right there, or to an artificial one, just as Mike was alluding to. One of the things we used to do is set it up to an artificial, like oldest is -1, because everybody's going to be older than -1, so therefore we'll do that. Or you can do it as the first value, one of the two. So then what would I use in here? I want to know who the oldest is in this loop.
Oh, are you asking us to answer that?
Yeah.
Well, we're just gonna do a comparison.
All right. No. Yeah.
Well, okay. What did you ask us to do?
I want to know who is the oldest at the end of this loop. Who was the oldest of all the people we put in?
Yeah. So
I'm just going to do it.
If age is greater than old, then old equals age.
Oh,
yeah. Now there's okay. Old equals age. Perfect. Other than it automatically capitalizing stuff, guys, because I'm in doc rather than coding here. Now, by the way, that is common. But notice what the question asked for.
Yeah. So now you just need to save it to old.
I did, right there, old equals age.
Oh,
But the fact is, I also asked for
Gotta-
who
gotta
was
save,
the oldest.
gotta save the name.
Everybody see this? So this works. This is great. By the way, this would be a beautiful multiple choice or output question. On my tests and quizzes, I will put problems and say, using this set of data, tell me what the answer to this, what the output of this question is.
But Don, it would only work once because you're never asking for the name again. And that's why you have to put the name inside the loop.
Well, what do you mean only work once? In all honesty, this loop would go for, this would work perfect for average. The average age would come out perfect.
But would the name change?
Your name would never change. So your name would always be the first name.
So you see what I'm trying to say? If this was a quiz question, you would do data, right? You see my point? That's exactly what I want them to see, isn't it? So what's the cure of that problem? And I hope I know what several of you are going to say.
You have to re-ask the name each time in the loop.
I like that. So therefore, I'm going to take that, right? You say, oh, Kirkwood, of course. I'm going to copy that sucker right down here. Right?
Don, I have a question about that line.
Yep.
The line that says name equals input, blah,
Right.
blah, blah. What does the comma age do?
Oh, it would show the variable age. That is the value of the variable age. So in this case, if you typed in, the first question was type in age, so I typed in 16. This would say type in the name that goes with 16.
Okay.
I always tell my students, I want the user input. I said the only thing dumber than a computer are people who use computers. So my job is to make the code as clean, as clear, as error-proof as possible, and that's one of the ways I do it.
John, don't we need to print the oldest?
Oh, good. Oh, good. Thank you. We didn't get that because I hadn't edited. Okay.
Hey, Don, does Python require you to declare a variable before you enter a loop?
No. You mean initialize? Careful, careful, careful. Initialize versus declare?
Declare, I guess.
Declare means int or float or something like that. The answer is no. But
Okay.
to initialize, I have given it a value. My answer to that question is I don't care, because I'm not teaching Python, I'm teaching programming. And some languages will, and therefore I don't want them to learn habits that say, you know, do I need to do age equals 0 or tote equals 0? Because the Python compiler will automatically initialize it to 0. I don't give a rip, because as soon as they learn C, no, it ain't gonna work, and guess what they're gonna be doing? So I'm teaching them the program, and initialization to me personally matters. So that's why I do it.
His question's really on scope, and oldest is only used once, and it's inside the while loop. And so you can't technically use it outside the while loop.
Correct.
Yes. And because you don't declare it. Since you don't declare it, you don't have to say it's a string, it automatically is. So that's okay. I like your idea, but in Python, we don't have to worry about that.
But are you going to be able to use oldest outside of the loop is what I'm saying.
Yeah.
Oh.
Yeah.
Does inside and outside only come into the radar when we're using functions? Like, and not loops then?
Oh, yeah, two things. If we're talking about declarations, because we don't have to declare variables other than type conversions, the answer, you are right. And we'll worry about that last function. If you, even there, variables are global if you don't choose to do otherwise. And we'll worry about that when we get to functions. Let's not get to that stage. But yes, scope really matters when you do functions or methods. In this case, though, let's keep focusing back on this. We have another issue. And that is the following. But by the way, let's backtrack. Would this work? And the answer is yes, it would work. If I was a counselor at your school and I have a new student coming in and I have to input all their data, right? If I'm a counselor or a secretary in the counseling office doing this, what sort of loop would I use? So my job is inputting new students data in. What sort of a loop would I use to do that job? Would I use a for loop? Am I getting any responses?
Yeah, sorry, Don.
Once again, let's go back and you say, what the heck does that have to do with each other? You're going to see in a second. So if I was a secretary in the counselor's office and my job was to input data for new students, so you're working at North, not Spring, because there's no new students. So North would be 25 every day. So here we go. If that's the case, what sort of, would I use a loop? If I'm inputting an unknown, if I'm inputting students into my thing, do I need a loop?
Yeah.
Yeah. Is it going to be a for loop?
Well, no, because you don't know how many you're going to have.
I have no idea whether it's going to be 0 or 93. Second, therefore it's unknown. Is it going to be a natural flag or artificial flag?
Artificial flag.
Yeah.
Because?
Again.
Because you don't know when it's going to end.
Yeah.
Yep, you don't have any idea when it's going to end, and there's no value that says, aha, we're done for the day. I don't have anything. When I read that problem, there's not a single word or phrase in what I verbalized that said, we're done. There's nothing there, right? So I got to make it up. It's an artificial flag. Now, think about this a second. If you're looking at this code, now I'll kick back to this, because I've seen your faces enough and we're in the rhythm. If I kick back to this code, if I was the counselor, I would have to be asking like 95 questions, correct? And just someone unmute yourself and everybody just say yes or no. So I hear a mass. So I would have 95 questions to ask, correct? And if I did that, and if I'm paralleling these codes, what would be the major issue here? Think a second. If I had 95 pieces of data to grab from the student to input, not only their age and their name, but a whole bunch more stuff, what would the code look like if I did that? And okay, wouldn't I, according to this code, I would ask for their name, ask for their age, ask for their address, ask for their phone number, ask for the parent's name, I would ask all those things up here, wouldn't I? Then I would have a while loop that says while name, while age is greater than 0, because I just chose to use that as my flag. Then I would do whatever I'm going to do, find the oldest, whatever I needed to do. And then what am I going to do? Ask all those questions again inside the while loop, correct? And then 2, when I quit. So I did that, and I do this, and I do this, and now I want to quit. So they type age is -1. And what are they going to have to do? Type in the address and the phone number and the parent's name and everything else for all of -1's data. But what? No! All -1 signified was, I'm finished, get me out of here. So did I want to input all of that stuff before the while? No. What did the algorithm say? The algorithm said get flag variable. Not get flag variables. There was one variable I used for my flag. Therefore, when I did this, no, I do not want the name here. I don't want all the other variables here. I want to do that variable only if my age wasn't -1. And here, I'm going to get everything else also. Now, does everybody see that? This follows the algorithm. Get the flag variable, go in the loop, and if it wasn't the flag, do everything else. Get all the other stuff. So they typed in an age. I probably use a student ID number or something like that if it was this, but get the age, it was 8. I go in and I get all the information for 8. And I figure out the oldest and I figure out the average, and then I'd say, what is your next age? And when you're ready to quit, type -1. And notice this would never be redundant. That's why that algorithm, get flag variable, while the do stuff, get flag variable again. That algorithm, and by the way, what you just did is perfect, because that is exactly what students are going to do, and I love setting them up for that, and then them going, oh, this is stupid. I'd much rather them figure it out as they're doing it, right? Because there's typing this, and they go, well, this is dumb. Well, what am I, oh, that's the best way. But if I need to trap them after the fact, that's cool. Does that make sense? Not seeing bodies.
Oh, I think it does make sense. I think I get a little hung up on reading it through the while loop and then seeing the exit. I don't know. Somewhere in there, I got a little bit.
Well, that's
lost.
why we have to practice. If this was real, once again, you'd be practicing 4 or 5 or 6 of these way before we even got to this stage. This isn't the advanced part of the while loop, because that's what I want to try once we get into it. But can you see what I'm trying to talk about? This is why online stuff sucks. I looked at like 20 of these online programs to try to recommend for people and everything else. They don't explain this. They don't set you up for this. They don't show this. They don't do anything with this. And this is real stuff. This is what will happen. And I want us in this conversation. That's why, like I said, maybe why I like teaching so much is that I made every stupid mistake along the way myself possible. And every time I was doing something, I'm thinking about, how do I explain this clearly to my students so they don't do the same stupid things I did? And that's where we need to, and this is good. You're stubbing your toe along the way too. That's fine. You'll know where it hurts, and you can either set your students up for that or prevent it. But frequently, that hot dog, we've been alluding to several times, that hot dog students, several of you alluded to, and we all have them. Guess what? They will stub their toe on this problem. And that's nice. Because I love them so much that I will help them. Okay, that's just, my exterior, they know the true soft heart inside. Right, Justin? Right. Yeah, good. That was good.
Can we go back to the code real quick?
Yep.
We were talking about scope before, and I wanted to point out something that I think is pretty important for everybody to know. So we did discover that if you enter the loop once, and oldest was never declared outside of the loop, it is inside of the loop, and as long as we enter it once, then it exists in this kind of global area within this space, and so we can print the oldest. However, if you do not enter the while loop once, you never created oldest to begin with, and if you're printing oldest outside of the while loop, you will generate an error.
And perfect, because what should we, this is great, Setson, because what should we, if we're doing this real, what else around here would cause an error if we didn't enter the loop at all?
The average.
Thank you. Nothing would work, right? Because average would be divisible by 0. Therefore, and this was alluded to last week when we were doing this, what do we need to do with an artificial flag? We need to have an if else that says if our count was 0, then we avoid all output anyway. Let's say slow day today, right? And we would avoid printing out oldest, so we would avoid printing out all of that stuff. Exactly right. Therefore, that would prevent those errors from occurring. The other way around it is exactly what you alluded to, declaring all variables, including oldest, outside the loop. I'm not declaring them, initializing them. I could have done oldest here. And therefore, if I made oldest to a null string, it is now declared, or better verbalized, initialized outside the loop. And therefore, if I printed oldest at the end without ever going through it, it would print a blank.
You're still going to get an error on the second to last line, though.
Oh, yes. That's why it's better to put the if then else, like I alluded to already. So notice, if you're doing data and you're doing any algorithms, you need to be thinking about what, so when we do max min, there's not a problem. Max will be 0. That's cool. But when you're doing, unless it's a name, if you're doing averages or stuff like that, part of that algorithm is to test to make sure you have some data to use. Exactly right. Exactly right. That's why it would always be better to have here if count. Why do I get looking at you guys and do other things? Count equals 0. Print. Whoops. I thought this and the strings aren't going right. So here we go. Print. Nothing else. That resolves all those conflicts, because I wouldn't be using that variable in that form. Okay, make sense? And the other way to do that, once again, especially if we were doing a function, as Judson was alluding to on several, once again, it might be appropriate to initialize. In all honesty, this is why I do like typed languages like C++ and Java, where you have strongly typed. You have to declare all local variables in there. As soon as you declare them, you should initialize them, and then that resolves all of our issues right there, rather than having the algorithm handle. But here we go. Okay.
So I have a question. I don't know if this is idle or what, but I don't normally put the comma on my input and print statements. I usually do the plus sign for concatenation.
Oh, we can do that, yeah.
I'm getting an error on the line with name equals input with the comma, but if I put the plus sign, it works.
Here?
Yeah, that line there.
Oh, you're right. With the input line, I'm sorry. With the input line, it has to be a plus concatenation because input demands a string, and that's all. So you're 100%. It's got to be a plus.
Okay, and then you have to put the str around age because it's going to be a number.
Well, it I think it will concatenate without it being. I think it will concatenate, but I'd have to go back and play that game. You may be right. I may have to typecast it.
I think you can only concatenate strings.
Okay. Yeah, unless it starts. I think if you start with an integer, then you can concatenate. But once again, that's one reason why I wasn't playing that stuff here, because I don't want to mess with the syntax so much as the other stuff. But you're right.
Okay.
Thank you.
So that was why, because input has to have just a string.
Input is it expects one parameter. I forgot that as I was typing. Input in Python expects one parameter. It's going to be a string. Correct.
Okay, I didn't know if that was just idle or what.
Nope, nope, it's Python, and my fault, sorry. I'm flying thinking about other pieces of the puzzle. This is the problem with coding 3 languages at the same time. I'm doing some other stuff in Java and going back and forth with little junker syntax. Oh, it's terrible during a school day. I love that. When I taught Python, Java, well, not Python back then. It was Pascal, C++, and Java all on the same day, period, across them. I don't know how the teachers do it in the same classroom.
Hey, Don, sorry, but Kim suggested putting an SRT around the age. What? I didn't hear whether it was or not necessary.
Someone can run it there and find out. I don't think it's necessary if it's in there, but it may be necessary to typecast it. It is necessary. Yeah.
So that's STR for string, STR.
Yeah, you're typecasting the age because it doesn't concatenate. By the way, once again, in Java and C++, you concatenate anything you want, and there's some potential things you got to watch for, but it works. Here, Python, when it changed away from its no typing at all, now plays some little weird games like this. So yeah, Kim, you might run it and find out and let us know specifically if you don't mind.
Yeah, I'm getting an error on the if statement. It says syntax error. So I'm not, if age is greater than old. So it must be something before that, but I don't know what.
Oh, if you're just cut, do you still have to get everything else also? I just put a phrase in there that wasn't code.
No, I don't have that in there. I have.
Oh, it's probably the plus. It probably is the plus age and the concatenation stuff there. If you guys want, I'll come back to this and type this code at clean, and we can come back to it later, and I'll kick it out to everybody.
Yeah, that'd be good.
Instead of taking, but we can, whatever you guys want, I'll print this out and get it clean so that we take care of all the little TV syntax stuff. That, once again, is if we were, as a matter of fact, in the intro class, those of you in there, you might want to wait for that because we will do that in the intro class. here at this class, we were trying to take the other potentials, but yes, we'll get back to that in the intro class real detailed. Okay? And I've got that there. I'll get it back to you this afternoon. Good, Kim. Check. Thanks for doing it. Like I said, those little tweaky things, I don't, in all honesty, I don't keep track of them as I'm doing it relative to other languages. That way, when I do stuff on the fly. Sorry. Well, I should be just doing Python, and then I would not have that excuse. Well, then I could pull the age card. I could pull that one, so that's okay. So I'll figure out some rationale for my student error there. There we go. Now, like I said, never know what we're going to get into here, and I like that. By the way, some of you guys wanted some projects and stuff, and I'm doing this for the intro class. Here we go. And we'll talk about the climbing out of a hole and stuff here in a second. For those advanced people, you want to do some stuff. There's kind of some cool stuff here. The last three are kind of fun. Even the first one. If you do the gambling stuff, and Mike and I used to always do this stuff. I always like doing gambling stuff in programming because it shows how stupid it is to gamble. I love those examples. When I taught Shermecca night classes, I always had one person that was taking the class because they had a method. They knew how to break the bank in Reno. And so they wanted to write the program to prove that their trick would work. And guess what? It never worked. And I love that. Just the other than counting cards, which then they throw you out. The one thing that you can do that's not cheating, they throw you out. But anyway, so in here, gambling is great because it shows why you shouldn't gamble or what the probabilities are. So pass line and field bet are really a fun group or advanced product. You start simple with the field rolling dice, and you expand it to field bet, then you expand it pass line, then you expand it to a player being able to choose and starting with an amount of money. And if they run out of money, so I'll set that all up. That's one. But climbing out of a hole, I'm going to verbalize all these because we'll see whether you guys want to do one of these now or not. But climbing out of a hole is a real interesting problem because I'll ask you, now, by the way, the pass line and field bet would be what type of a loop? I'm rolling a dice. Field bet is I roll a dice, and if I get certain things, so if I roll a dice, I get a 7 or 11, I lose or I win, and I roll a 2 or 12, and I get double my bets and all that stuff. There is no loop there at all. I just roll a dice, and I get whatever I get, and there we go. Pass line has a little real quirky thing is if you don't get specific things, then you keep rolling until you crap out or you get your point. And therefore, what type of a loop would that be? I keep rolling until I either get my number, I roll like a 5, or I get a 7 or 11. What type of loop would that be?
A while, natural.
Natural flag. It'd be a natural, because 7, my point, or the crap values are going to happen sometime. So it's going to be natural. Climbing out of a hole. Climbing this is a well. You have a well. You're at the bottom of the well. So you tell me the depth of the well. You climb up a certain amount during the day. If you don't make it out, you fall asleep and you slide down a foot or whatever you choose to do. And then the next day you climb a little bit more. And if you make it out, you're done. If not, you slide down a little bit. So how many days is it going to take you to climb out of this well? 4
Depends. Oh, 4 loop? No.
No.
It's going to be a while loop, right? While your elevation is less than 0.
And by the way, can you see this? And by the way, I have a graphic representation of this. So for your kids, by the way, there's a tweak to this one. There's a real, almost every student who does this one the first time loses points. I love this test question because the advanced one thinks it's so easy and they almost always lose it. That's a hint on the side. Yeah, and I've got a graphical representation here for you if you want to. Falling off a bridge, is it or a bridge or a dock? You're in the middle of a dock, a 9-foot dock, you're in the middle, and you randomly go either direction. We used to call this the drunk walk. We don't tend to call it that way in class anymore. But anyway, so random walk. So you take a step towards the water, you take a step towards the land, and you keep going back and forth until you either fall off in the water or you make it safely to land. So, for loop. Nope. Because I don't know how many steps. While loop, artificial and natural.
Still natural.
Everybody see it? With two possibilities, right? Land or water. And you have to figure out which way you're going to do it. So now, we can do one of two things right now with our last 10 minutes. We can look at one of these, and some of you could be coding it independently while the rest of us look at it, because I've got those in code, and we can look at them on your stuff. I saved them to you today. Or we can spend the first 10 minutes of this, the last 10 minutes of this thing, introducing and preparing you for the next discussion next week. So thumbs up means we do a code. We practice this a little bit more. Thumbs down, we practice. We go to lists and discuss this new concept and get prep for it. So I see thumbs up, code, thumbs down, go to the next stage next week. So there's one code, one next week, one next week, one next week. It looks like we're going next week. Those who want to, go play with those. And don't cheat by looking at my codes. Do your own. So let's talk about the next week's stuff. And we're here, so I'm going to go to this. If I give you this problem, and by the way, remember I tell you, have you noticed what we are doing is having the kids take that intellectual leap. And we are prepping them though. We're showing them how to build this sucker. We're not just throwing them off into the water from 20 feet above, which is what textbooks do. Here's a whole bunch of problems. Now learn. Now do 5 more on your own. And if they learned incorrectly or inefficiently, that's a habit that's built in, and it's really deadly 3 years down the line. We had a couple teachers teaching at North. Now, it wasn't Mike, of course, but there were some other people who would teach some of the intro courses. And at first they were learning or they didn't last in teaching very long. And they did some stuff, and then I would get them 2 years later or a year later, and they were coding. The habits were so hard to break because they had not been reinforced and created in the first place. So the leap is where we do it, and we have to think about that. So here's a question. Right after we finish all the looping and the decision test, I pass it back to them and I ask them this question. We talked about it a whole bunch here. Input, let's make it easy. Input 100 scores and output the average score. Let's assume that. So what would you do? Do we need a loop? Input 100 score, output an average score. Do you need a loop? Yep. What type of loop? There we go. Right? For loop, because you guys should all have your mics off and you should be going for it. I just love cacophony. The real life. This is a classroom setting here, guys. You can't whip out and fish out like this. So
we know the exact number.
That's what I should do like a real teacher. I should call on you. So therefore, that would be it. Oh, that would be fun. If I could de-mute you. I don't know if I can do that. I'll see. So it would be a
for loop with a defined number.
No, it's 100 students, 100 scores, right? So easy. That would be the simple test question. That's one of my C test questions. I always put them in the test. So now, right after we got on the test, I asked this question. I said, cool. We answered that question. It was very easy. I'm going to change that question just this much. And my question now is I'm going to have 100 test scores. And I want you to tell me, that's all I have is 100 scores. I want you to write the code that will tell me how many students got above average. Notice it sounds like almost identically the same question, right? So tell me how I could do that. And I would love to have someone jump into this. Go for it without any new syntax. You know nothing more than what I've taught you. So those of you with a vast amount of knowledge more, you can't use it. So you can pretend to be like you don't know anything right now. See, so I'm giving you an excuse. Here we go. But there are 2 ways to solve this problem with only knowledge that you have from constructs. 100 scores, tell me how many students got above the average score.
And you want us to do this without lists?
No, you don't know. What list? I don't know what the word list means. Yeah.
You have to find the average.
So what are we going to do?
Input scores.
So you got a for loop, and we just talked about it, right? You got that for loop and input scores. Cool. I'm listening.
Have a counter just to count the scores above average.
But what's the problem with that?
I don't know yet because I just suggested the solution.
I love it. I love it.
You don't know the average till all the scores are in.
Yeah, we don't know the average because I don't know the average, so I can't compare average to the score. So
Now,
how can I sign up with no other knowledge? There are two solutions to this problem. I didn't say they were good.
You can make 100 variables.
Oh, good. You see that? One way to do it is to do 100 variables. Now, don't laugh or anything else, right? We take an answer and say, does this answer work? And then we'll go back and critique it, right? Because a wrong answer now may be the perfect answer for the problem I have a month and a half from now. And if I didn't sit and analyze this answer, I'm not going to have that brain explosion a month and a half from now because I didn't have this foundation. So yeah, so we have 100 variables. So let's talk through that. Keep going. So what would I do with 100 variables? How would I solve this problem with 100 variables?
Oh, that I don't know if it's very easy to do that.
I didn't say it's easy. I said, would it work? Tell me an answer with 100 variables. How would I do that?
Actually, I don't know if you can. I don't know enough about Python to know if it has reflection capability.
Oh,
but
nope. Nope. You have no knowledge beyond what I've taught you.
You just
Are we allowed to ask the user to enter the information twice?
Well, now we got two answers going here. Hold up. Let's, Johnny, if you don't mind holding off on the side a second. We're not going to do the Microsoft answer yet. Do you want to quit? Are you sure you want to quit? Are you really, really, really sure you want to quit? So let's hold that answer off here aside. Okay. So let's go back to the 100 variables.
So what you could do, if you had 100 variables, you could have 100 if statements after you've calculated your average.
What would you have to do even before that?
Well, first you enter, after you've done your entry and you have your average,
so you
know what your average is, then you go through each of your variables with 100 if statements. Okay. And if it's greater than the average, then you add to a tally.
But even before that, would I be able to do a for loop with my scores then?
The dilemma is that if you have different variable names and you're not able to use pointers or reflection, then you're going to have to ask for information 100 times so that you can put the stuff into the 100 different variables.
So you're going to have to input 100 variables by 100 input lines, and then what am I going to have to do?
Add them all together so you can divide by the number.
Pumpkin line to calculate the average. Add them all together.
And divide by 100.
Charlie said I have 100 if-thens, and then I would know. Correct? Now, by the way, does this work? Yeah, it will do the job. And for the user, now here's really important point, guys. For the user, what's the benefit of this? Would the user even know that that's what you were doing? No. The speed of doing the 100 if-thens, the speed a little bit, that's nothing to a computer. So in all honesty, the user would know nothing underneath the hood. It would work, and it would do the job just as fast for them as any other choice. Now, you as a programmer, we don't like this. And it has, so does it work? Yes. Does it have benefit? Yeah, for the user, it's pretty straightforward. What's its deficits? Its deficits, it's insane amount of code, and what's the other big deficit relative to anything else?
It's a lot to sift through. It's going to be pages of code.
Yep. And it's also not flexible, right?
Yeah, no.
It is you can't change the number of bodies, everything going to be bad, all right? And since you, unlike a cannery where the machines are the only thing they care about, you, the programmer, are the expensive piece of the puzzle for a business. They don't want you to waste your time doing that because you are their money, right? So we got an answer that works. User, it's great, doesn't make any difference to them, but we have other issues. Now, for Johnny's, let's go back to her answer, her idea, which was what?
Giving the user a terrible experience was my idea.
Oh, good, good. Well, no, you're getting ahead of yourself, but I like it, but you're right. So what was go back to your answer, and before we do the negative, right, we need to say, do we have an answer? Does it work? Positive, negatives, right? You see what I'm trying to get? And I want them to start doing this ground zero so that they as teams, you guys alluded to, how do I get teams to work together? This is how we get teams to work together. As we begin to understand this stuff. And the young women say, no, I need to stand up. And that's what you have to do it. You're going to have 1 or 2 guys in your group or church who think they know the answer all the time. And guess what? They're usually wrong. They don't know the best answer. That's why the company hired you. You are here because of purpose. They don't spend money to hire people unless they're good ideas. So you need to get your name and your voice in here now. And these type of discussions kind of do it.
So two while loops, or rather 2 loops, and the first loop grabs the information, calculates the average.
Perfect.
And the second loop is enter that information again, and now I'll compare it with the average and tell you whatever by, yeah.
All right, so what are the benefits of this? No, first of all, does it work? Does everybody see it works? So we have 2 for loops, 1 to calculate the average, 1 to find out above average, and then we print stuff. That's cool. So does it work? Yeah. Benefits.
Well, I was trying to, oh, sorry, go ahead, Ron.
I was just going to say you don't need 100 variables, but I'll tell you the disadvantages. They could make a user error in the way that they enter the information.
Yeah, but they can do that with any of these options. You're right, but any of the options, users, like I said, they're one thing dumber than the computer itself. So that's another whole issue we have to deal with. But,
so what's tripping me up is the procedure for finding the average and then declaring an above average variable that equals greater than average.
Yeah. Yeah.
So
yeah.
Go ahead.
No.
Well, my concern was like, you want it to do that process and you don't want it to determine above average after every single input. You want it to do that after every single one of the 100 has been entered.
But so you have to enter it once. No, you can do it. So you get the average, and then the next loop, you say, get a score, and if score is greater than half, count +1. Get the next score.
But if you haven't inputted all 100 scores, then you don't know what the average is.
No, you have to do it again. Oh yeah, you did. The first loop you did a total. That's a summation. Inside the first loop, it'd be total equals total plus score.
Right.
Total equals total plus score. Therefore, at the end, ab equals total divided by 100. Because total was the total of all those scores at once.
Right. So you decided that average. It's only after that you can then count the above average scores.
Correct. Now you have to do another completely independent for loop and get all the scores again and compare them to the average. That's the devil. There we go. Now you got what Rodani was saying is the devil. So you have 1 for loop to get the average, and now the second for loop, you got to get the score again. And every time you get the score, you compare it to the new average you now know.
But you don't want to make the teacher input all those numbers twice.
No, but that's the solution. There we go. So the benefit is it's short code, right? It's insanely short code. You, the programmer, didn't have to do squat. The deficit is, unless your name is some big company, you ain't going to sell too many of these programs, is the poor user has to input the data twice, all right? That's what we got. So now, but notice, this conversation you're laughing and joking about, but guess what? Now, what tool do you want from me? What is the solution to this problem?
I want a variable that I can assign like a subset to, like S sub 1, S sub 2, so I can change the variable and then store the data as it's being entered.
So you want a variable that can actually hold a bunch of information.
Yes.
A variable that can hold a bunch of pieces. Now, by the way, most students, you guys cheat, and you are cheating now, because most of you know about lists for arrays or something. Many students that I had in Algebra 1 or just finished that freshman didn't know that. So I have to come up with an example. And since we're out of time, I'm going to give it to you. I always said, think about your psychology book, your sociology book, your econ book, especially. Think about that. And you would have charts in the middle of your book. And I would let them dig a lot harder for this than I'm doing with you guys. I'd say, you have a chart. What do we have? If you have 6 charts on a page with a whole bunch of information in each one, let's do an econ book, you would just say, if I said go to the gross national product one, could you do that? Yeah, because that's the title of that chart. And in that chart, you have multiple pieces of information. So that chart's title is GNP. That's what it is, population growth. We have pollution index, right? We have those, and we have a metaphor for exactly what we're looking for. I want a thing that contains a whole bunch of information. And that is what a list that they call in Python is. And now
So we can reference that and use it multiple times.
And by the way, that also makes a good name for your list, unlike most textbooks. Instead of calling them X or num or a bunch of other crap, you would say this is score, because what this list contains is score. A good title for this list of information is called score, or GNP, or pollution index, or whatever we've got. And now we're going to make a huge leap, because there are 3 real distinct algorithms relative to arrays that I've never seen in any textbook ever. Because if you ought to look on online and look at your textbooks, if you got lists, arrays, all they do is show you a bunch of examples and say, now, have fun, here's your problem, go for it. And that really sucks bad for students and for adults. The hardest thing ever was teaching adults coding when I got to arrays. They screwed up things so bad it was unbelievable. And that made me sit down and figure out how to teach it differently. Because
So Don,
yeah.
What I'm seeing you say is that we have created a need for lists through this example, and therefore we might get the buy-in that lists matter, and this is why we care about lists, instead of going, hey, this is how you work with the list, bam, 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 here are some examples. I get that, but I am dying to know, and I know we're out of time, but what I'm dying to know is it possible to do this problem without lists, without asking for the input twice, without using 100 variables?
I do not know of an answer, and I've done this exact question probably in 50 workshops, and no one has ever come up with one. And I've done it in class, I don't know, I've never had a student of any level do that. If someone could come up with it, I'd love it, but I can't think of one. I think the prerequisite is saying all we know is constructs. All we know is that tool. Can you solve the problem? And I cannot think of a way to do so. That's a good problem for the advanced people. Go for it. See what you can come up with. So this is a preface for next week. We will start with lists. We'll review this a little bit, and then I'm going to tell you something I worked my butt off to come up with, and I think it works very effectively relative to how to attack array problems. Because if you have taught this before, to me it was, well, Mike, not this Mike, but Mike Dunlap, the guy, the professor at Willamette, he used to say, arrays with a second level of confusion. And I said, what are you talking about, Mike? He said, yeah, variables were the first level. At high school, you lose a bunch of people with variables. That's why kids struggle at Algebra 1 even. Then now you put a variable that doesn't represent one thing, it represents 100 things or 5,000 things. Now go for that. Explain that to them, please. So that's what he said. But I think there are ways to do this that make it a whole lot easier for students. And that's what I want to teach next week, or show you guys next week. All right. You guys take me in the most circuitous routes to the cool. I love it. And it's really fun. This is why I like to do this, because I never have any idea what we're doing. Hey, oh, you're not supposed to hear that, Kathy. I know what I'm doing at all times, and I set it up for you guys to take me in this really weird way today. So
I logged back in because somebody said there Kirkwood's just having too much fun in this class. Go fix that.
Oh, yeah, so she shows up. Here we go. All right. Now we've got it. This is the end. We'll start next. So you can play with those codes, those homework things that I did. You might look at the codes because I gave you the codes for the well and for the plank. I did those. I didn't do the dice game because that's pretty straightforward. But I will come up with, several people asked me for like some project-based things, and I can set you up with some samples. So I hope to have them for you next week, written out more formally. So we'll do that. Good. Anything else?
I want to make a couple of requests for next time. I mean, of course, it could be based on consensus or whatever. One is talking about the difference between if-else and elif.
Oh, good.
Maybe with some examples. And then I know that today you gave us many scenarios in which we had to figure out if a natural flag, whether we would use a natural or an artificial flag, and like the well problem and stuff like that. Is there one place where I can just look at those questions and quiz myself on it?
I haven't put it out here, but I have like the start of the document that I'm trying to create that is a while back they asked me, long time back, to make a C tutorial that had all the planned course statement basically for a C course. And I'm now converting that and doing some big transitions to Python. But I have a whole bunch of those type things. I'll get them out there and I'll print them out. I'll show you that you can kind of just go through your brain and check through that. So I'll get 10 or 15 of those out there and do that. Okay?
Thanks, Don.
Sure. Other things? Is this going okay? I mean, it's not going the way I had planned, but I like it. That's actually more enjoyable to me personally, but this is fantastic. So as long as it's okay with you guys, all right, just let me know.
I think I would add that the conversations that are occurring are really helpful, I think, because in many cases they kind of mimic the things that our students are going to go through.
Yep.
And, you know, Python, even though I'm familiar with other languages, Python is new to me. And so there's a lot of things that I wouldn't have thought to point out to students until we start digging into this stuff. So it's very beneficial to me.
I think this is the best. That's why I say I think this type of a structure is the best because we are the learners, but we are teachers. So when we're learning, we have a whole little parallel universe going on that says, I struggle with this, and so how can I set this up so my students either struggle in a good way? I like struggle; it's great but I don't want them to struggle with frustration. I want them to get to a place where they're loving this and loving that challenge. And that's online stuff. I have not, if you guys find one that works, please share it. I have not been able to find one that does that for high school students or middle school students.
So Don, while we're over the week, should we try to tackle one of those problems on our own and see if we can solve one?
Or all of them.
Or all of them?
They're there for you to look. So try on your own. Like I said, don't look at the answers until you're finished. And you may come back with a better one. Mike was at the workshop in Wilsonville where the guy did a great example. I was teaching all these pieces of timing and all this stuff for the sieve of Aristotle, different types of sieves for prime numbers, doing a bunch of stuff. And this guy went on his own and he produced a code that was better than my example because it involved all these other pieces. And if we get to that stage, you're going to get his. So yeah, you come up with one that's even better than mine, which is a good, easy possibility. I'll steal it and we'll put it on there and have it that way. But yes, I would recommend that highly.
I think Nikos raised his hand. Nikos, did you have a question?
Oh, sorry, yeah, I don't. Yeah.
Maybe not. I don't know. I thought I saw a raise hand icon.
Yeah.
Just thank you. It was really interesting.
Oh, my bad, Nikos.
Oh no, go for it. Yeah, it's a hard problem.
I just wanted to throw this out there because, yeah, I am a stone cold coding rookie. I mean, I've done HTML and CSS, and Python I know is being used quite a bit in like web development by building applications and whatnot. So I'm not gonna lie, I've listened to all of it, got some notes. But if you called on me like you threatened earlier, deer in the headlights. Deer in the headlights, man.
No, I wouldn't do that.
But what I will tell you is the code is kind of moot because the code you learn more. I could learn that on my own if I absolutely had to. What I'm getting out of this, frankly, you're teaching me how to be a better teacher. That's what I do.
That's the fun part of what we do. And so to me, we talked, Kathy and I talked, if I could avoid the bureaucracy garbage, I would teach till I'm 90 because that part is just like the kids. I don't worry about them cheating because if we do this right, the learning is fun for them, and that's what we want to have happen. But we have to produce that environment, and you're going to do it so different than me, and probably better than me for certain students because the way you approach things and your personality will be better than mine. mine, I'm kind of passive and reserved, and so that doesn't always work. Hey. So, but there's the point. Exactly. Oh, I appreciate that. Yeah.
Well, and so learning is fun and teaching becomes more fun, I think.
Yep. So good. I thank you. I hope that's okay, because I worry about that sometimes, because I could teach the jargon a whole lot faster, the syntax, but that to me is way more minimal than this. So cool.
People don't want to leave you, Kirkwood.
Oh yeah, right. All right, guys. Fantastic. If you have other questions, I like when Johnny always throwing stuff at me and making me do homework. That's not the way this is supposed to work, but that's okay.
Sorry. Don, I have a question though.
Sure.
Do you have these problem statements written down? I'm not sure if I missed that. Like, I'm looking through the shared drive, and I would like, I'm having a hard time imagining the problem itself to be able to answer.
Okay.
So when you come up with these and then jumping back and forth, I don't have something to look at. I'm visual. And so do you have these problem sets written down that we can view, which would help?
I have them written down, and I will organize that in such a fashion to give them to you guys. And then I would recommend, that would be a good idea, is just to print them out yourself. And I will do that with the future reference one. Part of the reason I don't do that is just like today's conversation, where I had an outline for, that's not where we went. And where we went was most appropriate for you guys. But I can have that list at least that will help some of that stuff. You may interject into that list if there's a problem that fits, but at least it would give the core of what's going on. So yes, I will do that.
Right, and even for the things that you were suggesting to solve, like the well problem or the dock problem, like when I sit down to do this and think about it tomorrow, it would be nice to have a problem statement.
Okay, I will set that up and I will do that all the way. Yep.
Awesome, thank you.
Make him work, Jan.
Yep.
All right, thank you. Have a good one.
You also. Anybody else?
I need you for 5 minutes, Kirkwood. If you want to.
Thank you.
It's after time.
Thank you.
That's okay.
Have a good one, Don. I'm emailing you a copy of my drunken bridge walk code.
Oh, okay. From the past, yes.
It's got a little ASCII animation for it.
Oh, okay. Oh, you ought to look at mine. It's got the turtle graphics animation. So you've got it on the share folder that I did today. So it's not fancy, but it's got the boardwalk and a turtle going back and forth. So yeah. All right. Hope everything's going okay with Judson, with you and family and everything else.
Yeah.
You're in our prayers and stuff.
Appreciate it. Yeah, of course. Appreciate it a lot. Things are going really good right now.
Oh, good. Very good. Very good.
Good.
On top of everything else, you don't need that, but
yeah.
Life goes on.
Everybody.
Yeah.
Just glad things are going in the upward direction. Yeah, good.
All right.
This time.
See you, Judson. Have a good one.
You.
All right. What orders do you have for me now?
So you are having entirely too much fun. I'm just saying.
Otherwise, I wouldn't be doing this.
I know.
All of us, yeah. Well, I'm going to
what?
stop recording. Did you stop recording?
Oh, no, I need to do that. Sorry.
I just did that, yes.
Okay.